established the scientific laws that affect nearly all of our everyday experiences. For example, how the moon orbits the Earth and the planets orbit the sun, how a hockey puck slides over ice, how a person rides a bicycle, and how a rocket launches a satellite into space. In this video, you will be introduced to the person behind the connection of these laws. Well, the person who explains the connection between force and motion is Sir Isaac Newton. His laws, considered by many to be the most important laws of all physical science. Newton's laws are related to the concept of motion. In his work known as the Principia, published in 1687, Newton wrote about his ideas on forces and motion and readily acknowledged his debt to Galileo. He created 3 laws today called Newton's laws of motion. Then what are these 3 laws all about? The tendency of a body to resist change is called inertia. Thus, the first law is called the law of inertia. The first law of motion states that, number 1, an object at rest remains at rest unless an unbalanced force acts on it. Example, figure skater. To begin moving, a figure skater must apply a force using her skates. Once in motion, she'll continue to glide along the ice in a straight line for a long time unless she applies another force. 2. An object in motion will remain in motion unless acted upon by an unbalanced force. Example, a train is a massive object, therefore it has a lot of inertia. Once in motion, it is very difficult to stop, requiring a very large force to slow it. Another example is wearing a seatbelt prevents your body from continuing its motion if the car stops suddenly. 3. An object in motion will change that motion if acted upon by an unbalanced force. Example, a young snowboarder experiences a force due to gravity which pulls her down. She will move in a straight line unless she applies a force to the board, changing direction. Another example is when a jogger experiences many forces while running: gravity, the push of his feet, the friction of his shoes on the ground, and air resistance. His legs, together with the friction of his shoes, overcome his inertia to propel him forward. The change in velocity is called acceleration. Therefore, any unbalanced force acting on an object produces acceleration. Thus, the Newton's second law of motion is called the law of acceleration. This law of motion states that 1. An unbalanced force acting on a mass will accelerate it. Example, as the water flows over the edge of the rocks, gravity, which exerts a downward force on it, causes it to accelerate downward. The water moves faster the longer it falls. Another example is when a heavy bucket sits on the edge of the well. If someone pulls on the rope, applies a force that is stronger than the effect of gravity and the frictional forces on it, then the bucket will accelerate upward. 2. Motion and velocity of an object is related to its acceleration. The velocity of an object includes its speed and its direction. Acceleration is the change in velocity. So changing the speed and/or the direction of an object is an acceleration. Example, in a carousel, the children feel an acceleration because their direction is constantly changing as they spin. Another example is when a driver hits the gas. The wheels apply a force on the ground due to friction. This force accelerates the car forward. The brakes apply a force to the wheels, which in turn apply a frictional force to the ground, decelerating the car. So the gas pedal and the brakes are both accelerators, since they change the speed of the car. Because velocity is the combination of speed and direction, the steering wheel is an accelerator too. It changes the direction and therefore the velocity of the car. It is important to understand that the action and the reaction are acting on different objects. Thus, the third law of motion is called the law of actions and reactions. This law of motion states that 1. For every action, there is an equal and opposite reaction. Example, a rocket works by propelling mass out the back end at high velocity. The action of the mass of the burning fuel accelerating out. The back end applies an opposite reaction force to the rocket, moving it forward. The rocket is not simply pushing against the ground. This works even in the vacuum of space. Another example is when the man pushes the heavy box up the ramp. He applies a force to the box, and the box reacts by pushing back. If the man pushes hard enough, he can overcome gravity and friction, accelerating the box up the ramp. Suspension bridges are all about actions and reactions. The main cables push the support poles down, and the poles react by pushing back with an equal but opposite force. Cables hanging down from the main cables pull the main cables down, which react by pulling back on the vertical cables. The roadway hangs from the vertical cables, pulling them down, and the vertical cables react by holding the roadway up. 2. Force is necessary to start something moving when it is at rest or to change its speed or direction. Example, when the boy runs up to the ball and kicks it, he applies a force to the ball, moving it forward. The ball reacts by pushing back against the boy, which he feels as pressure on his foot when he kicks the ball. Another example is when the hammer hitting the nail applies a large force to it. The nail reacts by pushing back against the hammer. The carpenter feels this as a jolt backwards against his hand. The fish also propel themselves forward by pushing water back behind them. The water reacts by pushing the fish in the opposite direction forward. So, if you learned new things today, drop your comments below, like and share this video, subscribe and hit the bell button to receive notification from my upcoming video.